Hi, welcome to our next section of geometry, section 1.3, segments and their measures. Our goal is to find and compare segment lengths. A postulate is a rule that is accepted without proof. Another name for a postulate is an axiom. Postulates, like undefined terms, are the basic building blocks of the logical system in geometry. You'll use logical reasoning to prove general concepts throughout this course. Congruent segments. They're segments that have the same length. Given segments AB and CD, if they each have a measure of 5, then we would say that segment AB is congruent to segment CD. And you would mark that using these small hashtags. Because AB is equal to CD, then segment AB is congruent to segment CD. The symbol for congruence is an equal sign with a tilde over it. This means congruent. This symbol means congruent. The points on a line can be matched one-to-one with real numbers. The real number that corresponds to a point is the coordinate of that point. Point A corresponds to 2. Point B corresponds to 8. The distance between points A and B, written AB, is the absolute value of the difference of A and B. So the distance between A and B is equal to the absolute value of B minus A. So if point A corresponded to 2 and point B corresponded to 8, then the distance between A and B is the absolute value of the second x minus the first x, 8 minus 2. So the distance between A and B is 6. Segment AB is 6 units in length. Example 1. What is RT? This means what is the distance between R and T? Well, the coordinates for R are -7. The coordinate for T is 3. So RT would be the absolute value of the difference between them. So 3 minus -7. You remember that minus a negative, you're really going to add these together. So RT equals 10. You find SU. What is SU? What's the distance between them? S is located here at -4, and U is located at 8. SU is how many units in length? It would be the absolute value of the second x minus the first x. So SU is equal to the absolute value of 8 minus -4. SU is 12. So segments that have equal length are called congruent segments. In this case, we have segment AB, segment BC, and segment CD. We could also say we have segment AC and BD. Let's find two segments that have equal length. If we're looking at segment AC, 2 minus negative 4, AC equals 6. Now let's look at segment BD. 5 minus negative 1, BD equals 6. If AC equals 6 and BD equals 6, then we know AC is equal to BD. And if they are equal, then they are congruent. So we could say that segment AC is congruent to segment BD. The next postulate we're going to learn about is the segment addition postulate. If you have two pieces, you can put them together to get a bigger piece. And it's not only just for two, you could add several segments together, but this rule uses just two. If B is between A and C, then segment AB plus segment BC will give you the whole segment AC. Example 2, let's use the segment addition postulate. If we know this entire segment, E to G, is 59 units, we want to find out what are EF and FG. Well, what we do know is that if we added segment EF to segment FG, it would give us the total segment EG. This is the segment addition postulate. EF is represented by the variable expression 8x minus 14. FG is represented by the variable expression 4x plus 1. If we substitute in these expressions to the segment addition postulate, then if EF plus FG is equal to EG, 8x minus 14 plus 4x plus 1 is equal to 59. Now we need to combine like terms and isolate the variable. 8x and 4x are going to give us 12x. Negative 14 plus 1 is negative 13, is equal to 59. Now using the addition property, we can say that 12x is equal to 72. In the multiplication property, we can divide and say that x is equal to 6. Now that we've solved that x is equal to 6, we can substitute it in to find the length of EF and FG. EF is equal to 8x minus 14. So we want to substitute in the value for x. 8 times 6 minus 14. So we know that EF is going to equal 34. X equals 6. We know that FG is equal to 4x plus 1. So if we substitute in the value of x, 4 times 6 plus 1, we're going to get that FG is equal to 25 units. Using the segment addition postulate, we know that EF plus segment FG is equal to segment EG. So if we substitute in the values that we just solved for segment EF and segment FG, then we would say 34 plus 25 is equal to segment EG, which is 59. So we are correct. You may remember the distance formula from last year in algebra. In a coordinate plane, we can find the distance between 2 points, or the length of that segment, by using the distance formula. Remember that the distance between 2 points is the square root of the second x minus the first x squared plus the second y minus the first y squared. On your paper, it says example 2 again. This is actually example 3. We want to find the distance between the 2 points whose coordinates are given. So we have point A, let's graph it, at -2, 2. And point B, 0, -1. So graph these 2 points on the graph. Between every 2 points, there is a straight line. Between here, we have a distance. This forms segment AB. We can use the distance formula to determine the length of this segment in a coordinate plane. In the distance formula, we need to label a first point and a second point. It really doesn't matter if you call point A your x1, y1, and point B your x2, y2, or if you do it the other way around. You just have to keep the x and the y together. I'm going to name point A my x1 and y1. And point B is the x2, y2. Using the distance formula, I can determine the distance between these points on a coordinate plane. So the distance between A and B is the square root of the second x, which is 0, minus the first x, which is -2. Minus negative, I'm going to add, squared, plus the second y, which is -1, minus the first y, which is 2, squared. So the distance between A and B is the square root of 2 squared plus -3 squared. So the distance between A and B is the square root of 4 plus a negative number squared will always be positive, 9. So AB has a distance of the square root of 13. We can leave this as a radical. You do not have to simplify imperfect squares right now. Or you could say that you know the approximate value of this is 3.6. So segment AB has approximate value of 3.6, the square root of 13. That's the last section, the last bit of our notes for today. That was your homework. And you also want to make sure that you take the Edline survey that can be found on your calendar or under links. And please give us your honest feedback. That open response last one, we're asking for your opinion. So any suggestions or observations that you've made, things you've liked or maybe haven't liked, your feedback's important. See you on Monday. Have a great weekend.